Welcome to the third video in this week's solution series on the solutions in our course Competition, Policy and Strategy. So we are now considering exercise 8.3 collusion, and we are now extending the model to include a competition authority, right? And just to get the whole picture once again, in the first exercise of this week, we were considering the most simple way of considering collusion, which was a one-shot game. There was only one single period, and we were comparing profits under collusion, cooperation, with profits from deviating and profits from competing in the first place, right? In the second exercise, we were extending this model and we're including the possibility of there being multiple periods and really making this multi-period game. Now, in this third exercise, we are going to make the model ever so slightly more complex in order to incorporate the possibility of there being a competition authority. Because what the implication of this is, or what this implies, is collusion is not allowed, and now we want to model what happens if collusive behavior can be punished. And this punishment, of course, has a negative payoff for the firms that participate in collusive behavior. All right, how can we do this? Well, we are building on the exercise which we were discussing all along. So still the same demand functions, the same cost function, everything stays the same. We are now considering a case where, this is all the same, so firms are in Kono competition, but now there is a competition authority that with some probability rho, 0.2 in this case, detects a cartel agreement and imposes some fine called capital F. All right, so if the competition authority manages to detect the cartel, which happens with this probability of 20%, well, then all the participants will have to pay a fine, capital F. Now we want to analyze how these two parameters, or the existence of a competition authority, affects the critical discount factor delta. Because this, as a reminder, this critical discount factor delta was what decided whether or not a collusion could be stabilized between firms. And now if this critical discount factor increases, that means that, well, ceteris paribus, firms will, or a collusion will be less likely to be stable. So, that's what we are going to do first, and then afterwards we are going to consider a case where we introduce leniency, and under this we allow for a firm to report collusive behavior. And of course, if they report the collusive behavior, there is no probability for a fine, because probably would logically be 1, but at the same time the competition authority is rewarding this cooperative behavior in finding misconduct and is therefore reducing the fine to some lower F. All right, and then of course we want to have, we again want to consider what happens to the critical discount factor if we have a leniency program in place. All right, let's start with the first case. So, let's first establish some ground rules, and that is, well, if the expected fine, so the fine the firm will have to pay weighted with the probability of detection, so the expected value of the fine a firm will have to pay, if this would be larger than the profits under collusion, well, then trivially collusion would never be profitable. So in order to make this model interesting, let's consider a world where the profits under collusion are big enough that they exceed the expected punishments. because only then collusion can happen in general. All right, well then, the present value under collusion is no longer simply the profits of under collusion in each and every period weighted by the discount factor, but instead in each and every period the firm is now faced with an expected value of the fine, because there's some there's some probability of paying capital F, so we have this expected fine rho times F. So in each and every single period where firms act in the cartel, their profits are reduced by the expected value of the fine. Okay, and if in each and every period a firm is making net, so to speak, net profits that are defined by this difference, well then again the sum of this geometric series, as we have shown or as we have discussed earlier, can be written as this expression. Okay, so of course, why are we only looking at the profits under collusion? Well, if firms compete, of course they are not facing any fine or any likely fine, any expected value for a fine, because they are doing nothing wrong. So VC, or the present value of competing, does not change at all. And the same is true for the value of deviating, logically, because if we deviate today, well then there is no cartel tomorrow that will be able to be detected. So there is no, as long as firms are competing or playing their best responses and not engage in the cartel, of course there is no risk of being detected for this misconduct. All right, let's now consider first the slightly more simply world where there is no leniency program. So the only issue we will have to think about is this change in expected or in present value of the profits under collusion, because they will have to be reduced by this expected fine. So there is no leniency program, which means in the case of deviation, firms will in the first period, in this initial period in this world, get the deviation profits, but at the same time we will model this in a way where in this first period, even though the firm is deviating from the agreement, there still is an agreement, right? So logically, the firm still faces the probability, the expected fine of being detected, right? Even though they deviate from the agreement exists, okay? And as long as the agreement exists, there is the expected fine for the agreement. After that, firms are engaging in the grim-trigger strategy, so they are reverting back to a competition. So there is, of course, as we argued earlier, no reason to expect a fine. Now, the present value of these profits under deviation then can be written as pi d minus the expected fine rho f plus, and that's of course the present value of all future profits under competition starting from some period 1. Okay. Based on this, and of course as I've already argued earlier, the present value VC, so under competition, does not change at all. Not that it would matter too much for this exercise, because knowing VK and VD, we can already calculate the critical discount factor, right? Because what we defined earlier, what we discussed in the previous exercise, was the discount factor is the critical discount factor is that discount factor for which it is true that collusion is more profitable than deviation. So the critical discount, any discount factor that is larger than the critical discount factor, will allow collusion to be stable. That is, of course, written what was exactly what was written on the slide earlier, previous exercise there. So the present value of collusion needs to be larger than the present value of deviation. All right. So we have both of these quantities. We have Vk, we have Vd, so we can plug these numbers in and then solve for delta. This delta then is the critical discount factor. And what you will notice is, well, the only difference between the conventional or the previously defined critical discount factor and this critical discount factor that now includes the existence of a competition authority is this rho f in the lower part of the fraction, so with a negative sign. So this is, if the expected fine is increasing, this whole expression is increasing. All right. Now towards the second case, where we are asked to consider a situation where the competition authority is offering a leniency program. So we have a reduced fine, a lower f, smaller than capital F, but of course, because if you participate in a leniency program that happens with certainty, there is no expected value of this reduced fine, but rather this is a guaranteed reduced fine. All right, how does this change the present values of the relevant present values of sticking to collusion or deviating? Well, as long as firms stick with collusion, of course, they are not participating in the leniency program, right? So we can completely disregard this change when it comes to calculating the present value Vk. Vk does not change at all. Instead, Vk, so the present value of sticking to collusive behavior, is still the profits under collusive behavior minus the expected fine in each and every period where firms stick to this collusive behavior. So in this case, nothing changes. However, in the case of deviation, now we model this leniency program in a way that a deviating firm makes use of this leniency program. And there's one thing missing on this slide that would make this a lot more logical, I believe, and that is we conventionally assume that the reduced fine is smaller than the expected value of this fine, right? So in this case, of course, it is profitable for a firm to, profit maximizing for a firm to make use of the leniency program instead of, incorporating this expected value of the fine. All right, so everything else, of course, stays the same. So if a firm deviates, it still makes the deviating firm's profits for one single period, but this time it is not facing the expected fine from being part of the agreement, but rather, because it's making use of the leniency program, it receives the guaranteed but decreased fine lower f. Everything else, Grimm trigger strategy, remains the same, so that the overall expression for the present value under deviation becomes, as it's written down here, pi d minus lower f plus the weighted future profits under competition. All right. From here, of course, the strategy to solving this problem is exactly the same. We have Vk, we have Vd. So if we want to calculate the critical discount factor, we again make use of this inequality. So the discount factor is that delta under which Vk is larger than Vd. If we do this, if we plug in Vk, plug in Vd, and solve for delta, we find out that this is the new critical discount factor. And now, interestingly, we have the reduced fine in both parts of the fractions. And of course, we still have, because that part is unchanged, that comes from the collusion, the present value of collusion, we still have the expected fine in the upper part. So that's all that was asked until here. We were simply asked to state the critical deltas. Of course, it would be interesting, or it is interesting to now give some interpretations, some intuitions on how each of these scenarios impact the critical discount factor, and in how far the existence of a competition authority and the existence of a leniency program can help destabilize cartels. So let's consider these. All right, so in both cases, so in the case where we have a leniency program and the case where we don't have a leniency program, we see that for an increased fine, the critical discount factor increases and collusion thereby is destabilized. So an increased fine will in either case destabilize the cartel, the collusion. The same is true for the detection probability rho, which shouldn't be too surprising because firms are always considering the expected value of a fine and never only the absolute amount of the fine or only the expected the detection probability. This is a unity, and therefore it doesn't matter which of these two factors goes into one direction or the other. The important part is the expected value of the fine. So, little surprisingly, if the probability for detection decreases, the critical discount factor increases. So just the same as we saw earlier. So collusion is destabilized as well. So finally, a higher fine F and higher probabilities of detection contribute to destabilize collusion. So the larger the expected fine, the harder it is to stabilize a collusion. Then finally, coming to case 2, by introducing the leniency, the deterrent effect is strengthened in case the leniency program, the fine on the leniency program is larger than the expected fine overall. So, and of course, if we don't make sure that the reduced fine actually is smaller than the full-blown capital F fine and at the same time larger than the expected value of this fine, then we might actually see the opposite effect where we actually stabilize collusive behavior simply because in this case the reduced fine would be too small. Okay, so we have some substitutability of penalties and detection. So we have both of these levers, and given both mechanisms are in the appropriate interval, we can make use of any of these in order to reach the goal of the competition authority, which is to destabilize a cartel.